Okay, here's a video showing how to set up a tree diagram and then use it. So what we have here is a problem about urban voters. The voters in a large city are 40% white, 40% black, and 20% Hispanic. Please note Hispanics may be of any race in official stats, but here we're speaking of political blocks. So kind of different there. A mayoral candidate anticipates attracting 30% of the white vote, 90% of the black vote, and 50% of the Hispanic vote. Suppose we select a voter at random. Okay, so we're going to draw a tree diagram to represent this situation. So we're going to start by looking at the population as split into three distinct groups. So we've got white, we've got black, and we've got Hispanic. And so the whites, so picking anyone out, then we've got a 40% chance of picking white, a 40% chance of picking out someone who's black, and then a 20% chance of picking out someone who is Hispanic. And now we're going to think about them voting for this mayoral candidate or not. So we could go mayor, not mayor for each of the groups. Mayor, not mayor, mayor, not mayor. All right. So the probability of a white person voting for this guy or girl, whoever it is 30%, 0.3. That means they anticipate that 70% will not. They anticipate that 90% of the black population will vote for this mayor. That means they think 10% will not. And they anticipate 50% of the Hispanic vote, meaning 50% will not. All right, so each of the branches coming out from any given node, the branches coming out from that node all add up to 1, and then our end values, all of our leaves, will end up at multiplying to 1, or adding up to 1, sorry. All right, so the probability of someone being white and voting for this person for mayor is 0.4 times 0.3. It's and. So about a 12% chance of that happening. All right, the probability of someone being white and not voting for this guy, 0.4 times 0.7. So that's 0.28. So 28% chance of that. All right, so voter being black and voting for this candidate is 0.4 times 0.9. So that's 0.36. Voter being black and not voting, 0.4 times 0.1, 0.04. And finally, the probability of someone being Hispanic and voting for this candidate, or 0.2 times 0.5, which is about a 10% chance. And then this one also is 0.2 times 0.5, also 10% chance. If we add all of those up, they will add up to 1. So we have 10, 20, 30, 40, 50, 60, 70, 80. Yep, they all add up to 1. Okay, so now we can answer the questions. Find the probability that this voter votes for the mayoral candidate. Show your work. So we have randomly chosen a voter. We know nothing about them. Just did they vote for this mayoral candidate? Well, they could be in 3 groups. They could be these voters, or these voters. So they could be in any of those groups. So we have 0.12 or, which is plus, 0.36 or 0.10. So 0.12 plus 0.36 plus 0.1 equals 0.58. So 58% chance that any voter at random voted for this candidate. Given that the chosen voter plans to vote for the candidate, find the probability that the voter is black. All right, so given that it is a vote for the mayor, what's the probability that the voter is black? All right, so we have 0.58 voting for the mayor. We just found that out. So just out of the people who plan to vote for the mayor, so that's 0.58. Then we have, there's here, this group right here are the ones who were both Black and voted for this person. So 0.36. So Black and voted for this person out of the people who voted for this person. So we have 0.36 divided by 0.58. Grand total of 0.621. So about a 62.1% chance that out of the people who said that they plan to vote for this candidate, 62% of them are Black. Let me know if you have any further questions.